Hello and welcome to our 3870 motor torque sensor. Team members on this project were Ben, Mohammed, and Amanda in Professor Dietrich's class. Our project objective was to create, calibrate, and determine limitations of a sensor capable of analyzing torque in small-scale applications.
A permanent magnet DC motor was used for this application. The governing equations for this motor are derived from the VLU and VLI laws. The equation of interest shows a direct correlation between torque and current through the constant Ka. The equations also show that this is a first-order system with a single derivative.
We have different setups for static and dynamic as shown in the pictures here. For static, we wrapped a fishing wire around our sensor with a weight apparatus attached to simulate an input torque. For dynamic, we added a band brake that could simulate a step input with a quick change.
We had three main parts to our testing procedure: static, dynamic, and uncertainty analysis. Here you can see our static setup. You're going to see a set of weights being pulled up by the motor, and then the sensor is going to register the torque in the computer program in the background. We did this for multiple weights. Here you can see our dynamic testing. So first we had to get the setup equipment in the proper place by allowing the band brake to rest against the motor. Here we're starting the computer program that's going to collect our data. Finally, we remove the band brake from the motor to input the step response into the system. Lastly, you can see the computer program register our time response.
The total uncertainty of the sensor was 0.0007 Newton meter. The bulk of the uncertainty stems from the instruments used for measuring radius and mass and resistor in parallel to the sensor. This would be the ideal place to limit errors in the future. In summary, the sensitivity was 22.912 amps over Newton meter, tau was 0.0166 seconds, and the total uncertainty was plus or minus 0.0007 Newton meter.
The application range for this system is a small-scale torque sensor, and its uncertainty on the static data can be reduced with finer measuring equipment. Its repeatable time constants were evident in dynamic testing, but the limitations are due to system friction and added length to the torque arm by the fishing line. Overall, this project reached all the goals we set out to complete. We have accurate static and dynamic calibration, as well as an accurate uncertainty analysis. The advantages of this sensor included small size and relative cheap cost in order to complete precise torque measurements.